Hi, everybody. Hello, and welcome to Multi-Tenant Rails. This is the presentation where I talk to you about giving a database to each one of your customers. So, like, you get a database, and you get a database, and you get a database, and you get a database. Everybody gets a database. Now that I've got the Oprah meme out, we can focus on business. I'm here to introduce you to a gem, active record tenanted, that 37 Signals is open sourcing. In fact, I just pushed the publish button on it about 2 minutes ago. And this gem is intended to, it provides multi-tenancy. And I'll go into all those details today. I do want to talk a little bit about why we need a new library for multi-tenancy. So multi-tenancy is not a new topic in the Rails world. As early as 2009, Guy Nauer gave a talk on Rails 2 and multi-tenancy. This is a really great talk. It's a little dated now, but if you want to go take a look at it, he talks a lot about all of the problems that have to be solved, both in active record, but also the rest of Rails. So anyway, this is not a new problem. And in fact, data isolation has been solved several times. There are a couple of gems already that do this. So if you go to IBM's website, because IBM invented multi-tenancy, everyone knows this, IBM says, each tenant's data is isolated from and invisible to the other tenants sharing the application instance, and they use words like privacy and security. And this is really the core bit that I want to talk today about. I'm not going to talk about like database architecture. A lot of people want to talk about using things like materialized views. I'm not going to be talking about any of the database technology necessarily. I'm going to be focused on the Rails applications that you all maintain and what the Rails framework could be doing better to support you when you build a multi-tenancy app. I'm also not going to sell you on multi-tenancy. I'm going to assume that you know if you want multi-tenancy. So I'm not going to try to sell you on it. So this is just going to assume that you're here because you're really interested and don't need to be sold. Where am I going with this? Right. So data isolation, at least in the Rails ecosystem, takes two forms generally. There's a spectrum here, but I'm going to break it down into two. Commingled data or separate databases. Separate databases is what I'm going to be talking about, but I'm going to cover both of these just so that we all have some shared context. So commingled data is you have one database, and all of your customers' data is mingled together in this database. The idea is you have a tenant ID or an account ID of some kind in every table. So every row has an ID that you use to filter by your tenant ID or your customer ID. And the constraint is you have to remember to specify your tenant ID in every query. Here's what this looks like in practice. You might have a users table. We've got some people in here. We've got my friends Adrian and Peter, who both work for the same company. It's Shopify. Then we've got 3 different Jeremys who all work for different companies, because we have a lot of Jeremys in the Ruby world. This is our data. You can see we have an account ID column telling us where it is. And the access tenant gem provides a lot of this functionality, but you have to do the normal Rails thing. You add an account ID column to your table, you call access tenant, which sets up the belongs to association with the account. And if you need to do extra things like scope your uniqueness constraint to unique within a tenant as opposed to unique within an entire table, access tenant lets you do that too. The API that it provides for you is you call a with tenant block and you provide your current account. And then inside that block, if you're going to do a query to your database, it's going to automatically scope it. So like I think Access Tenant uses like default scopes for this magic. It's pretty good. And if you don't have a with tenant block, it'll raise an error and tell you, I don't know which tenant you're querying on. And this is a good thing. This provides the safety mechanism. Now, if you don't mind commingling your data, Access Tenant is great, and you should totally use it. And you can like leave, and you don't need to listen to the rest of the talk. But if you want to, oh, sorry, one more thing. The downside of this is you have to add the account ID to all of your models, which in my mind makes it really kind of an application level concern. You've got to make sure you've set up all of your models the right way. If you forget, things are going to go bad. And worse is sometimes your developers need to know that all the data is commingled together, which means that there could be a bug introduced where accidentally you might get data from one tenant being shown to another tenant. And this is bad, and I think the framework could be doing a little bit more, which is why I like separate databases. So the idea with separate databases is you have a separate Maybe if it's SQLite, it's actually a separate file on disk for each of your tenants. But this also works for Postgres or MySQL. For Postgres, it'll create a new schema. For MySQL, you'd create a new named database just for each tenant. And the isolation constraint, the safety, is provided by you only have one connection active at a time. So that connection, that database connection, only has access to one tenant's data, so it's very, very hard to accidentally show data to the wrong tenant. Now, the drawback, though, is you now have a lot of databases to manage, and you have a lot of connections to manage as well. But those feel like things the framework could be doing for you. And so this is why I like this, too. There's actually a gem that presents this isolation model. It's called Apartment. It's been around since 2011. And the API provides us pretty simple. You can create a new tenant, and this will do exactly what you think. It'll go create the database. Inside a switch block, if you make a query, an active record query, it will use the right connection to go serve your query, which is great. And if you do it without that context, it'll raise an error. Very cool. You can see that there are actually no other application concerns, and the framework is doing all of this work for you. One thing I don't like is the fact that you need to do this switch here or with tenant for the previous gem I showed you. In reality, though, there's middleware that does the switching for you. So pretend you don't see that for right now, right? So all we're really talking about is making sure that you can query the right database at the right time. OK. Once again, commingled data, kind of an application level concern. Separate databases, kind of a framework concern. I know what you're thinking. Hey, smart guy, why don't you just use Apartment then? So there are two reasons, I think, when we started to build Fizzy, which is our new application of 37 signals, that Apartment wasn't really fitting our needs. And the first one has to do with connection management. So Rails 6.1 came out in 2020, and it provided horizontal sharding and multi-database support. And these features were implemented with thread safety in mind. Thank you, GitHub. Thank you, Alien. So the idea here is that, Apartment dates back to 2011. And the way it manages connections predates all of this magic, and it's actually not thread safe. So there is like an open issue on Apartment dealing with Puma threads where it doesn't work properly. And so I saw this, and I saw like a path to tenanting support that used thread-safe connection management. Maybe it's a little bit more performant as well. I'm not the only person who saw this path. Earlier this year, Julik Tarkanov. Is Julik here? Julik. Anyway, Julik published a short one-file implementation called Shardine, which is a really great name. I wish I had thought of it. Basically, he says the same thing here, like, hey, Rails 6.1 has better connection management. And so it felt really good to know that other people had seen this opportunity as well. But I didn't use Shardine, and I didn't use Apartment. And that has to do with the second reason, which is completeness of the solution. So Apartment and Shardine both handle active record, and they handle the rack middleware necessary to figure out which tenant to use for a request. But it doesn't really do anything with the rest of Rails. Like, what about action cable? What about active job? What about active storage? It doesn't really do anything there. So it felt to me a little bit like, I keep hitting the wrong button. It felt a little bit like this to me, where like step one was, you configure your models in the middleware, super easy. And then step two is like, make the rest of Rails work. Make the rest of fucking Rails work. What I wanted to do is I wanted to make multi-tenancy omakase easy. Specifically, I want to have modern thread-safe connection management, and I want to have tight integration with every Rails component. So the omakase defaults that I chose for the gem, and it's just a default, you can change the configuration, is to take everything that inherits from application record, right? So this is your application's default connection class. Assume that everything that inherits from that is tenanted. And then also to say that we're going to use the subdomain of the request to figure out which tenant it is. So if the request comes into foo.example.com, foo is going to be the name of the tenant that gets used. And so the gem will inflate all of the context for you. So if you assume these two defaults, then it's dead simple to get up and running with a multi-tenant app. How simple, you ask? Good question. This is a slightly simplified version of the pull request to Fizzy, which is our new product, changing it from a single tenant app to a multi-tenant app. Like, no bullshit. This is it. At the top, we obviously add the gem. In the middle, we kind of annotate our application record class with tenanted. And to be honest, we could probably skip that too. I just haven't gotten there. And at the bottom, we are modifying our database YAML file. And specifically what we're doing here is we stick in a %tenant format specifier, which means that for whatever tenant is currently in context, that's where that SQLite database file is going to live. Side note here, everything I'm going to be talking about today is about SQLite support, but there's no reason that this gem can't be made to work with Postgres or MySQL. So if you're interested in doing some of that work and helping out, let me know. So if you make these changes, your tenant will be multi-tenant. There is no step two. Like, this is the dream. This is what I wanted to build. And Fizzy in particular, this is just a screenshot, but you can say it's like really nicely designed. We have a team of developers and designers working on this, and none of them know anything about tenanting. They just do their job like it's a normal vanilla Rails app, and it just works. So for me, that's like the key. I don't need to worry about tenant data safety if there's actually no opportunity for developers or designers to accidentally leak data. It just works. So let me talk a little bit about the work that the gem does inside Active Record to make this magic happen. And I want to start with explaining why the multi-database support inside Rails 6.1 is so amazing. So if you're not familiar with it, here's the brief version. You can, in your database YAML file, you can define shards. And in this case, shards are a group of databases that share the same schema. So the idea is you can have a set of models that can pull their data from any of those shards. So in this case, I've got two shards, shard 1, shard 2. In my application record base class, I say, these are the shards that the models can possibly read from. And then if I need to, I can switch away from the primary connection by calling connected to and pass in shard 1 or shard 2, and it does exactly what you think it does. So I took a look at this, and I thought to myself, what if we turned this to 11? Could I create 10,000 databases using vanilla Rails sharding? And so this is what I did. I created 10,000 tenants. In the database YAML file, I used herb to just generate 10,000 entries. Application record, I passed all of those entries into the connect to call. And then inside the app, I was calling connected to. This time it's tenant 1 and tenant 2. So you can see where I'm going with this. Like, each shard is going to be a tenant. Now, the surprising thing is this kind of worked. Two things highlighted. These are my notes from the experiment. There are good reasons why we should absolutely not use vanilla Rails tenanting out of the box for this. But the really interesting thing is that it totally worked. Like, once the app booted, I was able to get response times of like 7 milliseconds. Like, it just worked. It managed 10,000 connections to databases. And I was like, OK, there's something here. To summarize the pros and cons, the pros are that it's battle tested. It's been in Rails for 5 years now, totally thread safe, and it has the same kind of block calling semantics that I really liked, where you call connected to do, and you have a block where that tenant is in context. And I like that API. The cons all have to do with the fact that you have to declare all of these shards statically, like at boot time. You can't dynamically add a new tenant or a new shard. Really slow boot time for the process. It took about 2 minutes to boot up 10,000 database connections. And they needed about 2 gigs of memory to do all that. So like, all right, what if, can we come up with a way to do this dynamically? I was convinced that we could. And then I started to dive into the code. And I started looking at all of the classes that coordinate to do connection management in Rails. Abstract adapter, connection handler, connection pool, pool config, pool manager, database configurations, database config. And I got lost. It was really, really confusing. So the sense-making exercise I like to do is to draw pictures. I'm not going to explain this picture to you. Don't panic. This is mainly just illustrative of the complexity. These are all the different classes that I just named that have to coordinate to manage your connections. And I'm going to call your attention up here in the middle, which is connection pool. Connection pool is what represents a connection or a set of connections to the database. And so this is what I wanted. I wanted a new connection pool for every tenant, and I wanted to be able to create that on the fly when the tenant was first referenced. In the upper left-hand corner, you have active record base, and pretty much any active record query is going to call, super small, I'm sorry about that. That method is connection pool. So there's a method called connection pool that does a little dance and then returns the connection pool object. So looking at this, I was like, okay, I can re-implement some of this dance, but what we really need to do is avoid having to inject a database configuration at boot time. Okay, pretty pictures, go away. This is the first problem I ran into. I don't want to have to specify 10,000 entries in my database YAML file. I want to have one entry and have that act like a abstract base config kind of a thing. So how do I actually get Rails to understand what I'm trying to do here with a %tenant format specifier? So here's what I did. I created a new class called rootConfig. The details of that aren't necessarily interesting. But I used a register DB config handler. So Rails has this little known method that allows you to register your own handler to create database configurations at boot time. And the way it works is I look for that tenanted equals true key in the config. And if that's true, I return the root config object. And when I ask Rails for the configurations after boot time, you can see that first line is the gems root config. So what I've done is I've managed to inject my own class into the lowest possible level of the database configuration stack. And this is the shim that I needed to do some magic. So now that I have this root config, what can I do with it? If I just take a look at the root config and I ask it for its database, it's still going to have the %tenant format specifier, which is not useful. But there's a method on it called new tenant config that creates that concrete config for a specific tenant. And if we ask it, it'll have foo as the tenant name, which is exactly what we want. And we pass it into established connection to create our connection pool. We can see that it's got the right shard name. So I'm skipping a lot of magic here, but the idea here is I've got a tenant-specific connection. When you mix in tenanted into application record, this is the magic that happens. There's a method called current tenant. So tenants and shards are the same thing. This is just a nice little method to refer to everything as a tenant instead of having to mix and use shard in some places and tenant in other. And the connection pool, this is exactly what I just showed you. I check to see if the connection pool has already exists. If it doesn't, then I go through the dance and I create the new pool and I return it. I'm skipping a lot of complications, though. That's a very simplified code. There are a lot of edge cases that I had to handle. Maybe the most notable one is we can't connect to the database during boot because there's no tenant. If there's no tenant, there's no database. And so it's kind of this bootstrapping problem where we end up relying on the schema cache really heavily. I'm not going to go into detail here because I think it's a little boring, but I've done a lot of the heavy lifting. And the API that it presents is a little bit different than the gems I showed you already. So you can see that, first of all the methods hang off of application record. So we've mixed in the behavior into your base class instead of into like a constant or a module that their gem is bringing. So you can ask what tenants exist. It'll tell you. You can check for tenant existence. You can create a tenant. By default, this current tenant method is going to say nil, because there's no tenant context yet. We don't know which tenant we're talking to. And if in that lack of context we make a query, it raises an exception. If we specify with tenant in that block, everything does what you think it does. Current tenant returns the name of the tenant. We can make a query. And then the object that gets returned also has a tenant attribute now. And that works for both the model instances and associations. And we can use the fact that all these objects have now a tenant attribute to do some safety checks. I want to make it really hard to accidentally connect to the wrong database. So here's an interesting use case. If I fetch a user record out of the foo database, and I try to do an update, it's going to raise an error, because I'm not connected to a database yet. I'm not in that with tenant block. If I do it in the wrong tenant, I'm in tenant bar here, it's going to raise another exception telling you you've connected to the wrong database and not let you do it. These are great safety mechanisms. It also does this for associations. If I try to call .comments, it's going to behave the exact same way. And finally, the gem is not going to let you change tenants willy-nilly, like whenever you want. If you're in tenant foo and you try to switch to bar, it's going to raise an exception unless you've specified prohibit shard swapping. This is just vanilla Rails horizontal sharding functionality. But you can also, if you can call with tenant a million times, it's OK. And this makes it a little bit easier to provide your own method calls that will set tenant. And this is OK. All those examples had with tenant being called all the place, and I mentioned that middleware should usually take care of this. And I want to just explain really quickly how the middleware works. It's just a rack middleware class. If you're familiar with rack middleware, there's a call method that wraps everything else that happens during request processing. And so in this case, we take a look at the request, and we use the tenant resolver, which is, I'll explain in a second, it's a configurable lambda. We map the request to a tenant name, and then we wrap the rest of the request processing in with tenant. So this way, in your app, you don't have to call with tenant everywhere. It's already been called for you, and so that way you can act like it's just a normal vanilla Rails app, and you don't have to, your code doesn't need to know about tenanting. The way this is configured, there are two configuration params. One is which class are we going to tenant, which is connection class. And tenant resolver here is a lambda that just returns the subdomain. And this is the default omakase config. And as long as that connection class is present, the middleware is injected automatically for you. So all of this just is there for you. And if you want to do something more complicated, you override tenant resolver. Maybe worth noting, in Fizzy, we started with a subdomain tenanting, and then we moved to like a path base where the account ID is in the path, and we have to extract it. But all that complication is still limited to the tenant resolver. It's still in one place in our initializer. So I think this model works really well. OK, so I've talked about the active record bit, but now we need to talk about how to draw the rest of the owl. So this is going to be a little bit, I'm going to speed up because I'm low on time. But this is going to feel a little bit like I'm a salesman. I'm just running down a list of features. I'm going to slap the hood of the car and tell you, this baby draws the whole owl. OK, real fast, here we go. So again, back to the connection class. This is what controls all the Rails integrations. You can set this to nil if you want to have special behavior. But as long as that connection class is set, you'll get a bunch of stuff in Rails for free from the gem. So one great feature that's built in is handling all of the Rails records. So if you use action text active storage or action mailbox, you know that these Rails libraries create their own models. And we want these models to still be in the tenanted database, right? We want to be able to do joins between a comment and an attachment and a blob, for example. So everything kind of needs to be in the same database. But Rails makes all of these subclass active record base directly. So there's no way for us to inject all of our behavior from application record. The exception that gets raised has a hint here. It says, make sure to use subtenant of. Oh, interesting. Subtenanting. That sounds like exactly what you think it is. Subtenant of basically forwards connection pool from the active record, from the Rails records over to our tenanted class. So when you call subtenant of and pass in application record, under the hood, we just delegate current tenant and connection pool to application record. And this is kind of a neat hack you can use for a lot of interesting things if you were evil. But we're using it for good here. It's fine. But the end result of this, though, is that if we are in a tenanted context, we can ask active storage record, what's your current tenant, and it will know. And the connection pool is identical, and this is how we do joins across all of our models. And if we ask for the actual connection, we can see that shard foo is set. So all these Rails records are going to be using your tenanted connection, and this is exactly what we want. Let's talk about the fragment cache. The fragment cache for most Rails objects, by default, is going to be something like, here it says users/1. It's like the table name and then the ID. And if you've been paying attention, you know that that's going to be a conflict. We're going to have a lot of records in the application with ID 1. So there's going to be a user ID 1 in every tenant. So something like this could totally happen where you're going to get you're going to display a cached version of foo's data to a bar user, and you don't want that. If you're using solid cache, one solution to this is that you could use subtenant of on solid cache, which means that essentially all of solid cache is going to be in that tenant database too. So the cache isn't mingled with all of your tenant data together. It's one cache database per tenant, and that works OK, but it only works if you're using solid cache. What if you're using memcache or Redis? The solution is to actually modify the cache key. that Rails returns, and we just jam the tenant ID into the end of the cache key. Now it's unique, and now if you go back to the situation where you've got a fragment cache, everybody's going to get their own entry. Works pretty good, not too hard. Active storage has a similar problem where the blob key is what's used to actually store it in S3 or in your disk store. And that means all of your tenant blobs are going to be mixed together. It makes it hard to delete a tenant's or one tenant's blobs, or to maybe give them a zip file full of their blobs. So what we do is we do the same thing. We stick the tenant ID on the front, though, so that everything is in a distinct folder on S3, or it's in a subdirectory if you're using the disk store. So this is good. Well, kind of similar patterns coming up. But a really interesting case is active job. So in code like this, we're kicking off a job with tenant foo. We have a user record being passed in as an argument that's from tenant foo. Like, how the hell does this work? When this arrives in the job worker, how does the job worker have any idea what you're talking about? So the way we do this is we extend active job base. We add a tenant attribute, and we make sure that when the job instance is created, we check to see if there's a current tenant in context, and if so, we save it off as the attribute. When we serialize the job, the tenant is serialized and deserialized, so when it gets stuck into the job queue table, that will be there. And then perform now checks and says, oh, is there a tenant attribute? If so, I'm going to wrap perform now in a with tenant, and that way the job just knows what tenant you intended to run this for. And you also haven't broken the untenanted case, where you just want to run a job and you don't care about tenanting. That still works. Imagine this scenario, though. You've got a user that you pulled out of tenant foo, and then accidentally, you're in a different tenant context, and you call perform later. Like, do the safety checks cover this? They don't, actually. So we have to dig into global ID. And global ID is the gem used to serialize Rails objects. And normally, similar patterns everywhere, right? Normally, the ID is application name / class name / ID, and this is going to have the obvious conflicts. So if we don't do anything, this is actually going to delete the wrong user's comments. We don't want that. So we go into global ID, same pattern. We add the tenant name onto the end of the global ID, make it unique. And then we have to make the locator class also unique. So locator is what actually goes to the database and fetches the thing for you. If you give it a global ID, you ask for an object back, it needs to know that, in this first case, user is a tenanted model, and we haven't given it a tenant attribute. So it's going to refuse to handle that. It'll give you an error saying this is an invalid ID. If we try to load a tenanted record not in the context, it'll raise an error. If we do it in the right place, we'll get the object back. And if we use the wrong tenant, we'll get the wrong error. So all the safety checks from active record are also present in global ID, which is great. And so if we go back to this case, the job is going to fail with a literate exception saying wrong tenant error. And this is exactly what we want. Action cable is a lot like the middleware, where we can use that tenant resolver proc that you've defined to figure out on an action cable connection which tenant is in the context for that connection. So every user will have a tenanted action cable connection, and then any commands will get wrapped with tenant as well. And finally, turbo frames and streams and a lot of other pieces of Rails use global ID under the hood, and so everything just gets tenanted kind of automatically. Like, making global ID support tenanting really got me a long way. Action mailer base supports the %tenant specifier, as do a couple of other components. And load async, interesting edge case. If I call load async in foo context, but that doesn't get resolved until later when maybe I'm in a different context, it's smart enough to handle that as well. It'll give you back the right user from the right database connection. So if anything goes wrong, SQL query logs will include the tenant in the log. And also normal tagged logging kicks in as well. And if you're going to go to Adriana's talk about structured logging later, I still have to make it support structured logging, but I'll get there. OK, we're almost done. Testing frameworks, your tests shouldn't have to know about tenanting either. So, like, by default, all of your tenants are going to get all of these things. I'm not going to go into detail. Just trust me that I've thought about how to write tests for all of this. And in summary, this baby draws the whole owl. OK, a lot of details. I'm sorry about that. Looking ahead, I would like to do a few things before I ship a 1.0 of this, but really what it boils down to is trying to manage the connection pools. Like right now, it's possible if you have one request each from 10,000 customers, that you're going to have 10,000 connection pools in memory. That's not going to be a good scene. So what I want to be able to do is set a cap on the number of connection pools and then reap unused ones over time. And this will make it a little bit more manageable. With SQLite, that's not a big deal because creating a new connection is pretty fast. It's just a file descriptor. I'm not sure how that's going to perform with Postgres or MySQL, but I would like to find out with somebody here who will help me with it. A couple of rough edges, specifically around database task support. And this is because database tasks are, I'm not going to make a judgy comment, but like it's really complicated to make database tasks work well and to override their behavior. So I really need to put some work in on that before I cut a 1.0. And with that, I just want to let you know this is open source now. I just pushed the button. If you'd like to go to Basecamp Active Directory Tenanted, you can try it out. I would love feedback on this to see if it solves anybody else's problem as well. If you're thinking about using SQLite in production, you're probably going to want replication. So hang out in this room after lunch. Kevin McConnell is going to give a talk about SQLite replication. And thank you for your patience and for coming to my talk on multi-tenant Rails.